All right, class. So our first physics problem is going to be super easy. Okay, not going to lie, it's just multiplying, dividing, and then you're done. The second one is going to be a major challenge. Right? It took me a few days to figure out how will this be explained, and I think I've got a good explanation, but you're the first class to receive it. So let's see how this goes. Let's do the easy one first. So everyone go to Lecture, Displacement Graph 1, and let's solve for how much area is covered by a space probe. Oh, take out your notes, and let's see if we can make sense of physics in space. Alright, this physics problem says a space probe accelerates uniformly from 50 meters per second at t equals 0 to 150 meters per second at t equals 10 seconds. How far did it move between 2 seconds and 6 seconds? So we haven't done a problem like this before, where there's a range of time and you have to find the distance in that range of time. We've done one moment in time and another, like an x final. We've solved for that. We've solved for v final, but we've never solved for distance as a range, as an area. So we have to graph whenever there's a big range, like 2 seconds to 6 seconds. Our problem gives us 50 meters and then 150 meters as the lowest and highest speed. So on your paper, go ahead and create a y-axis, maybe like 4 rows wide if you're using binder paper, just on the side. 0 would probably be at the bottom. Not probably, it would definitely be at the bottom. So let me give you that quick, maybe I should type it. So let's do this. 0 meters per second. Okay. So you've got 3 increments, including the 0. It doesn't have to be exactly evenly spaced because we're not going to use a ruler and measure how long the distance is. We're going to use math. So this is all visual to help you see the big picture. Now that you've written down how fast this space probe is moving, we need to write the seconds. And the lowest number of seconds is 0. The highest number of seconds is 10. So you'll need an x-axis that has 0 through 10. And just make estimates of the distance between each. Okay, it doesn't have to be exact. When you do this on your practice problems, your study guide, and your exam, you're just going to draw an estimate. And it's very helpful to do this. If we did this with just the equation and multiplication, it's easy to take the wrong value. All right. So you've got your y-axis, you have your x-axis. I think I can move these now. And the space probe accelerates at 50 meters per second and 150 meters per second from 0 to 10 seconds. So we're going to draw a line that starts from 50 and ends at 150. for the whole time frame, 0 to 10 seconds. Let me give you rulers. Now this is not a ruler to measure the length of the line. It's a ruler to just draw a straight line. Okay? Straight lines will give you advantage. It doesn't have to be like a perfect length. Try to draw straight. And we'll definitely need it for the next problem as well. Some late students coming in, so a few extra. So we got this slope of the space probe going at this speed. Now this shouldn't be new. Anything that speeds up should have a line going up. But what's going to be new in this class is how far did the space probe go from 2 seconds to 6 seconds. So I want you to draw a vertical line at 2 second and 6 second, because everything in that trapezoid, this shape here, is going to be the distance the space probe can travel. It might be 2.1 seconds, it might be 3 seconds, it might be 5 seconds. Whatever number of seconds the space probe is traveling at, everything here will be the distance. Does anyone know how to find the area of a trapezoid? I did not know this offhand. I had to look it up, and so don't feel bad if you don't know the area of a trapezoid. Does anyone know the area of a rectangle? This you should know. What is it, Xavier? Length times width. Length times width, right? So the trapezoid is almost a rectangle, right? It's got 4 sides. It could be a rectangle if we cut off this top corner. But the formula for a trapezoid is going to be the following. Average of the 2 heights times the width. Average of the 2 heights times the width. Pretty easy to remember because look, there's one height up here, there's one height up there. Find the average, and that'll give you the height that Xavier is referring to. And then the width is given is 4 seconds. Devin, is for you. So this trapezoid is going to be the amount of distance between 2 seconds and 4 seconds. Distance, we learned, is x. And according to that sentence above, the area of a trapezoid is one of the heights plus another height divided by 2 to find average times width. So that's our formula. I'm going to get rid of this background so it's easier to see. So once you know the formula, you just plug in. A lot easier to do than the other physics formulas. No square roots, no exponents. Just add, divide, and multiply. So our x is going to be 75 plus 12. Oh, so let me tell you how I got 75. So here is here's where you're going to need your ruler. So right at this corner, at 2 seconds, it's in between 150. So this is where you're going to give yourself an estimate. Now, if you can show me on your graph that you estimated your distance, your speed, and then you plugged it in, it might not match my answer key, but it should be kind of close. It should be within a few meters per second. But here, you can estimate with your ruler, was it truly between 150? And then at 6 seconds, you can estimate the distance to be, keep saying distance, the velocity to be 125. So we've got 75 right here at this corner, and then 125 at this corner. Maybe I'll draw a dotted line. So you really need a graph to make this solvable. And it's mostly because of that estimate between the velocities given. So we're saying this is 75, and we're saying this is 125. Now we can plug in. You use your graph to solve. Now we can plug in. Where's my mouse? Oh, I unplugged the mouse. Okay, let's use this then. Okay, so we plug in. Hello. All right, let's do it from here. 75 plus 125 divided by 2 times 4. Let me call a student to do this math. Melanie, if you could grab your calculator and add 75 plus 125 divided by 2 times 4. Try it one more time, and let's do it one step at a time. So 75 plus 125 divided by 2. Just do that chunk first. So 75 plus 125 is 200. 200 divided by 2 is... So you guys are getting 137? It's 400. So look, let's take it a step at a time. Go here. This fraction should be 100. So whatever order you put in your calculator, that might have affected your outcome. So don't do that order. Instead, just do 75 plus 125, hit enter. Divide by 2, hit enter. Then multiply by 4. Mouse is working. All right, so Melanie, what was your final answer? Yes, 400. Okay, and that's how you do the displacement graph. So I guess it wasn't as easy as I promised. I guess it was easy because it was already done for me. But when I explain it, this graph is really important. And so is the estimate between the velocities, because that's what you plug in here, which is what you get here. And then this part down here should be very clear how to solve. If you didn't get 400 this time, punch in your calculator differently so you get the 400.